Hello everyone and welcome to this detailed lecture on the evolution and history of artificial intelligence. In this session, we are going to take a deep and structured journey across the timeline of AI, starting from ancient philosophical ideas all the way to today's cutting-edge generative models and future possibilities. AI's evolution has been shaped by mathematics, logic, neuroscience, engineering, computing power, and human imagination. Understanding this history will give you a strong foundation for learning modern machine learning and neural network. Let's begin with the earliest root. I am Dr. Mehar and we discuss the history of AI in very detail. Early foundation of AI, antiquity 1940. The desire to create artificial being with intelligence can be traced back thousands of years. Ancient myths from Greece, Egypt, India, China, and Middle East describe mechanical servant, talking statues, and automated artifacts. Although these ideas were imaginative, they show a timeline, they show timeless human curiosity. Can intelligence be created? Can a non-living object behave like a human? As we closer to the modern time, the philosophical exploration shifted into mathematics and logic. Aristotle introduced the foundations of formal logic. His work laid the conceptual basis for reasoning, an essential component of AI. Centuries later, in 1800s, George Boole introduced Boolean algebra. Later, Gottlob Frege, Bertrand Russell, and Alfred North Whitehead advanced formal logic and symbolic reasoning. These developments were crucial because they enabled reasoning to be expressed mathematically, making it possible for machines to process logical statement. In 1936, Alan Turing published a landmark paper introducing the concept of universal Turing machine, a theoretical device capable of performing any computation. This idea laid the foundation of modern computer science. By 1950, Turing proposed the famous Turing test, asking the question, can a machine exhibit intelligent behavior indistinguishable from a human? These ideas marked the philosophical and scientific beginning of AI. Birth of artificial intelligence as a field during 1943 to 1956. In 1943, Warren McCulloch and Walter Pitts proposed the first mathematical model of an artificial neuron. This was an early attempt to mimic how the human brain works. Researchers like Norbert Wiener explored feedback system and control mechanism, bringing biological and computational ideas closer. The Dartmouth Conference in 1956, the true birth of AI happened during the Dartmouth Summer Research Project on Artificial Intelligence. John McCarthy, Marvin Minsky, Herbert Simon, and Alan Newell predicted that the human intelligence could be precisely described and then replicated by machines. This conference established the term artificial intelligence itself and launched AI as a formal academic discipline. Researchers were extremely optimistic. They believed human level AI would be achieved within a decade. The golden era of symbolic and rule-based AI during 1956 to 1970. This period is also known as symbolic AI or good old-fashioned AI and shortly GOFAI era. Key achievements during this period: logic theorist 1956 often considered the first AI program, general problem solver JPS, designed to solve a variety of the problem using logic SHRDLU 1970, a natural language system that could understand command in a block's word, the first expert system program that encoded knowledge from domain expert. The approach symbolic AI relied on handwritten rules, logical reasoning, knowledge representation, symbolic manipulation, In many, these systems resembled early vision of the ChatGPT ancestors, but without learning capability. There was some limitations. Despite promising the result, symbolic system struggled with real-world complexity, ambiguity in the language, the need to manually code knowledge, and scalability. Yet this era set a strong foundation in logic, reasoning, and problem solving. First AI winter 1974 to 1980. As expectations exceeded real capabilities, the limitations of early AI became apparent. Funding dropped, research slowed dramatically. This period is known as the first AI winter. Major challenges include limited computing power, expensive hardware, overpromised result, lack of real application. Despite the downturn, key ideas such as machine learning and neural network quietly continued to evolve. Rise of expert system 1980 to 1987. The 1980 saw a powerful resurgence through expert system. AI programs designed to mimic the decision making of a human specialist. These systems used large collection of if-then rules. For example, MySyn, a medical diagnosis expert system, provided result comparable to skilled physician. Industries including finance, aviation, manufacturing, and medicine adopted expert system for fault diagnosis, scheduling, quality control, decision support. For the first time, AI had commercial value. Second AI winter during 1987 to 1993. But expert systems were difficult to maintain, too rigid and unable to learn from the data. As hardware cost increased and system failures grew, another crash occurred. This led to the second AI winter with reduced funding and skepticism. However, behind the scenes, a new approach was gaining momentum: data-driven AI. The machine learning revolution 1990 to 2010. In the 1910, AI shifted from rule-based system to learning from data. This marked the beginning of the modern machine learning. And the key concept introduced like statistical learning, supervised, unsupervised, and reinforcement learning, probabilistic models, data mining. Major breakthrough during this period was sport vector machine, decision tree and random forest, boosting techniques, Bayesian network, reinforcement learning algorithm. The internet revolution created massive data set, computing power increased. The machine learning method outperformed symbolic AI by learning patterns directly from the data instead of relying on manually written rules. This era defined ML as the backbone of the modern AI application. Deep learning era 2010 to present. Around 2010, AI entered a completely new era, say deep learning. What happened? This revolution, availability of the large dataset, GPU acceleration, improved neural network architecture. Key milestones during this period. During 2012, ImageNet transformed computer vision with unprecedented accuracy. 2014 to 2016, deep learning advanced speech recognition, face recognition, and robotics. 2016 to Google DeepMind AlphaGo defeated the world champion in Go. 2017, transformer architecture was introduced, changing the landscape of AI. And impact of this period, deep learning system became capable of understanding the natural language, recognizing object, generating image and text, driving cars, predicting disease, powering recommendation system. This era represents the rise of large-scale neural network, big data, and automation. Generative AI, cognitive AI, 2020s to present. We are now in the generation of generative AI, where models can create new content, text, images, code, music, videos, and even reasoning sequence. Core technologies which we are using: large language model, say LLM, diffusion model, multimodal AI, reinforcement learning from human feedback. As AI is now capable of complex decision making, human-like conversation, automatic content generation, multi-step reasoning, scientific assistance. This stage represents the closer integration of AI with the daily life and industry. Future directions of AI. Looking ahead, AI is expected to move toward artificial generative AI intelligence, a strong human AI collaboration, more powerful multimodal, explainable and trustworthy AI, autonomous robotics and self-evolving system, AI-driven scientific discovery. Ethical, societal, and safety consideration will become more important as AI grows more capable. So, this is the now closing remark, and the details about to contact us are given at this place. AI has grown cyclic of optimism, challenges, breakthrough, and re-innovations from symbolic logic to machine learning, from neural network to generative models. The evolution of AI reflects human ambition and innovation. In the next lecture, we will explore the fundamental concept of machine learning and understand how models learn from data. Thank you for joining this session, and I look forward to continuing this journey with you. Thank you.